Hello, 7th graders. We are starting a brand new chapter. You do not need to write any of this down. So I don't want you to think you have to write any of this down. However, Chapter 6 talks about linear equations and their graphs. Here are the 8 sections that we are going to go over. Now, we're going to take your previous knowledge of graphing linear equations using slope and apply it to harder problems, which will take your grasping of the concept much more in depth. Here are the key vocabulary terms for the entire chapter. You don't need to write any of this down, but I thought it kind of gives you an idea of where we're going to go. We are starting with section 1 of chapter 6, which covers rate of change and slope. Alright, this next part, I just want you to watch. You do not need to copy any of this down. So let's watch and look at this together. It says, the diagram at the right shows the side view of a ski lift. Notice that the vertical position is in feet, the horizontal position is also in feet. What is the vertical change from A to B, from B to C, and from C to D? So let's start with vertical change. I'm going to abbreviate vertical change as VC. Now from A to B, the vertical change is, let's see, here it's 40, here it'd be 50. So the vertical change would be 10. From B to C. B to C. So let's see, here it is 50. And then B to C, it goes all the way up here to 90. So 50 to 90 would be a change of 40. And then from C to D, what would the vertical change of B to C, or C to D be? It'd be from 90 to 100, so it's also 10. Now example 2 says, what is the horizontal change for the same values? So A to B, B to C. So horizontal change. We want A to B, B to C, and C to D. So now, what is the horizontal change of each of these? Well, A to B would go from 20, looks like 20 to 50. So 20 to 50 would be 30. Then from B to C, looks like it goes from 50 to 80. That's also 30. And C to D goes from 80 to 110. That's also 30. Find the ratio of the vertical change to the horizontal change for each section. So once again, A to B, B to C, and C to D. So A to B, the ratio of vertical to horizontal. So the ratio would be 10 to 30. So that'd be 10 thirtieths. 10 thirtieths simplifies to 1/3. B to C would be 40 to 30. That would be 4/3. And C to D would be 10 to 30 as well. That would also be 1/3. So which section would be the steepest? Which section would be the steepest? B to C. Why? Because the slope, which is your ratio, is 4/3. That's the highest slope. How does the ratio for that section compare? We just said it's the biggest. It has the highest ratio. Which leads into this. In the graph above, segment AB and segment BC have different rates of change. Here's what you need to write down. Vocab word. A rate of change allows you to see the relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. Your rate of change is the change in the dependent variable, change in the independent variable. Now remember which letter represents dependent here. That would be the change in y. Your vertical position depends on the horizontal position, where this is going to end up. So your rate of change is the change in the dependent variable divided by the change in the independent variable. So example 1, we're going to find rate of change looking at the table. So here's what the directions state. For the data at the left, is the rate of change for each pair of consecutive days the same? What does the rate of change represent? So we have to find the rate of change from every day. So let's look. We want to find the rate of change. Now I'm going to draw arrows from here to here. From here to here, from here to here, from here to here. So we can write them as a rate of change. Now remember, this is important. The rate of change is what? It's your dependent variable divided by the independent variable. Now in this case, the dependent variable is your rental charge, your change in cost. This is your rental charge because your rental charge is dependent on the number of days. So for each area, so we're going to write this 4 times. So we can see here that the first, from day 1 to day 2, the rental charge goes up $15 and the days goes up by 1. So look at this. The change in the rental charge goes up 15 and the number of days goes up by 1. That gives us a ratio of 15 to 1. Then we look at the next day. From 75 to 90, it goes up another 15. From 2 to 3, it also goes up 1. Then, from 90 to 105, now we subtract, that's what we're doing, we get 15. 3 to 4 goes up 1. 105 to 120 goes up 15. 4 to 5 goes up 1. Notice that the rate of change for every consecutive day is 15. Our rate of change, which I'm going to put as ROC, is 15. So the question is it the same for all data? Your answer is yes, it is the same. So what does the rate of change represent? The rate of change is 15. What does that mean here? The number of days goes up by 1. This is where your labels come into play. Look at this, rental charge. That means each of these mean rental charge, which is dollar signs. So it'd be $15. The number of days is what's on bottom. So each of these have a label of days. So this means it'd be $15 per day. So you would write that, what does it mean? It costs $15 per day to rent a computer. And that is what your rate of change means. This section I just want you to watch. It goes along with example 1. If you graphed all of these as ordered pairs, for example, this would be 160. This would be 275. If you graphed all of these ordered pairs in your table, you would get this graph right here. 160, after 2 days at $75, and so on. The graphs of all of these ordered pairs in example 1 lie on the line is shown. This makes a line, therefore incredibly important. This is linear. You can use a graph to find the rate of change. Here's what's the best part. All of the rate of change for every one of these was the same. It was $15. Because the rate of change is the same, you have a linear graph. Now recall, the independent variable is your horizontal axis. Ding, ding, ding. Independent variable, horizontal. That's your X. Dependent variable is your Y. Now example number 2. This is found on page 309 in your book. We're going to find now the rate of change instead of using a table by using this graph. The graph shows the altitude of an airplane as it comes in for a landing. Find the rate of change. Now here, rate of change. Remember, please always remember a rate of change equals your dependent over your independent. It's always Y over X, vertical. Change over horizontal, vertical over horizontal. So we know here vertical over horizontal. We know that means it's going to be altitude over time, which is going to be feet over seconds, hence feet per second. So what you do is pick any 2 points on this graph. I'm going to pick the point right here. 60, 100, 1,000, it's given to you. Then the second point is 180, 0. I want to know the change in vertical. Now remember, vertical, that's your y. That's your second value. What is the change from 1,000 to 0? We can subtract 1,000 minus 0. That gives us 1,000. But then we have to start with the x's. Your change as horizontal is going to be 60 minus 180, which gives us negative 120. We divide. That gives us negative 8 1/3. Now, in the context of this problem, we must put labels with it. Now, this is what the great part is. You can just look at what you had prior. What was this? This was feet per second. So we know this is feet per second. Now, what does that mean? That means this. The airplane descends, because that goes down, 8 1/3 feet per second. So every second, the plane drops 8 1/3 feet. Now, the next example is talking about slope. Now, you've talked about this before. Some roads are steeper than others. So you see the car has a steeper slope because it has a greater rate of change than the truck. So a slope of a line. This is important. You must know this. Slope is your vertical change, which is your change in y. Important. Change in y over your horizontal change, which is your change in x, which is called rise over run. So let's use that to find the slope of a graph. So look at this, example 3. Find the slope of a line. You can pick any point you want on this line to find the vertical change over the horizontal change. So watch what we're doing here. Slope always goes left to right. Slope goes left to right. Slope goes left to right. Repeat after me. Slope goes left to right. Don't forget that. So to go from this point to this point, we go up 2, right 5. What's the vertical change? 2. What's the horizontal change? 5. So therefore, the slope is 2/5. This is a positive slope. Positive goes uphill. Positive goes uphill. Positive goes uphill. This one goes downhill. Downhill. So it's going to be negative. So let's do this. This says down 3 units. Down 3 units. Because it goes down. 1, 2, 3. That means down is negative 3. That's my vertical change. My horizontal change, my change in x, goes 1, 2, 3, 4, 5. Therefore, that's right 5. My slope is negative 3/5. Don't ever make the mistake about positive or negative. Positive is a line that goes uphill. Negative slope goes downhill. So, you don't need to write these down. Just pause the video and see if you can figure out the slope of these yourself. Hopefully, vertical change. 1, 2, 3. So that means it goes up 3. Vertical change of 3. Right 1, 2, 3, 4, 5. That means we have a slope of 3/5. In part B, we can go down 1 over 1, 2, 3, 4, 5, 6. Down 1 will be negative 1, a change of negative 1 on the vertical axis. Right 6 means that we have a slope of negative 1/6. Which leads to this. You can count, like we did, up 1, 2, 3, and so on. But there is a formula, which you should already know. Slope. You can use any 2 points on a line to find its slope. You use subscripts to distinguish between 2 points. In the diagram, x sub 1, y sub 1 represents the coordinates of P. X sub 2, y sub 2 represent the coordinates of Q. To find the slope of the line PQ, we can use the following formula. Here's your key concept. Your formula for slope we know as change in y. To find the change of any two y values, you subtract them. So we're going to subtract our y values on top, subtract your x values on bottom. On the bottom, x cannot be 0. Make sure you understand that this right here, if you subtract them, it cannot be 0. Now, keep in mind that when you calculate slope, the x-coordinate you use in the first denominator must be the same order pair as the y-coordinate you use in the numerator. So notice here, I can start with either ordered pair, but make sure if you start with the y value of one ordered pair, you start with the x value of the same ordered pair. Here's an example. I want you just to find the slope of this line. Now, you could graph this. You could take a and b, graph it, and then count up and over or down and over. You absolutely could do that. But we have a formula. Our formula, if you remember, is y2 minus y1 divided by x2 minus x1. Now what that means is that you could take the x and the y and the x and the y and you just subtract them. So that means you could take 7 minus 1. That's subtracting the y values. Then we subtract the x values. Negative 2 minus 6. Whoa, I just did something wrong. What did we do wrong? Right here, on top, I started with the 7. And then on bottom, I started with the other ordered pair. You cannot do this. If I take y2, which is 7, minus y1, which is 1, I then have to start with the x2. 6 minus negative 2. That means I'd have 7 minus 1 is 6, 6 plus 2, which is 8. My slope is 6/8, which simplifies into 3/4. Now you could have taken the same thing, and instead of starting with the 6 and 7, you could start with the 1. So you could have done 1 minus 7. And then negative 2 minus 6. That would have given you negative 6 divided by negative 8, which would have also given you the same slope of 3/4. Notice that this slope goes uphill. Vertical change is 3, which is change in y. Horizontal change is 4. This is what your little keep in mind thing was that I just went over right before this problem. That when you use one of the coordinates, so for example, we start with 7. For the y, you have to start with 6 for the x. So 7 minus 1, 6 minus negative 2, 7 minus 1 was 3, 6 minus negative 2 is 8, 6/8 simplifies into 3/4. All right, the last thing we're going to go over. The last thing is horizontal and vertical lines. This is the last example we're going to go over. Now, in A, we have a horizontal line. If you found the slope here, remember, subtract the y's on top, subtract the x's on bottom. So if you remember our slope, y2 minus y1 divided by x2 minus x sub 1. So if we subtract our y values, you're going to get 2 minus 2. If we subtract our x values, 4 minus 1, that gives us 0 divided by 3, which is 0. The slope of any horizontal line is 0. Don't ever forget that. The slope of any horizontal line is 0. If you go to B, we have to find the horizontal and vertical change. So let's do change in y first. Our y values are 2 and negative 1. 2 minus negative 1 is 3. Our x values, 4 minus 4, that gives us 0. 3 divided by 0 is undefined. Therefore, any vertical line has a slope of undefined. Hence why this is not a function. This cannot be a function because it crosses the same y value at two different points. And to summarize everything you just learned, a line with a positive slope slants upward from left to right. A line with a negative slope slants downward left to right. A horizontal line has a slope of 0, and an undefined slope is vertical.